Well, we're going to talk about angles and circles, but first, the first page is going to be pretty much review over the several concepts that we've talked about in circles. Okay? Anyway, central angle and arc are always equal. Okay, so that's 39. So GA would be 39 degrees. Okay, TB is this end. So this is 39, this is 39 because they're vertical angles, 39, 39, 39, and TB is also 39, right? And then ATB is here around here. So that's a diameter, so that's got to be 180, right? GAB starts from here and goes all the way around to here, right? So we've got the 180 involved, right? The 180 here, and then the 39 as well. So you add those two together and you get 219. Okay. TRB is an angle, which we already found. TRB is that angle right there, 39 degrees central angle. And then GBA is all the way around this way, okay? Everything except for the 39. So it's 360 minus the 39 for GBA, right? And that would be 321. Okay? All right, so we talked about inscribed angles last time, and that's half the intercepted arc. Okay, if this is 80 and the vertex is on the circle, then this angle is an inscribed angle and it's half of 80, which is 40. Angle jet is 40. Okay, JCD 120. So the central angle is 120, and then JED, well, let's go ahead and write that down, 120, right? Then this is an inscribed angle that has this same arc, this 120 arc, right? But if it's an inscribed angle, it's half, so that's 60 degrees, okay? Here, the vertex is on the circle, so it's an inscribed angle, even though this is outside the circle, it's a tangent, okay? So you've got a chord and a tangent together. So if Joe, this arc is 200, then this would be half. This angle would be half of that, so it'd be 100. Okay, JE is this side, right? If this side is 200, then you take 360 minus the 200, and you'd get 160 for JE. Whoops, I'm about to write JE for some stupid reason. So that's 160. Okay, 200 minus the 360 is 160. Okay, 90, that's a 90. You can tell because it hits the ends of a diameter, right? This is the ends of a diameter, so that's 180 around here, right? So this would be half, which is 90. So angle DJE is 90 degrees. Okay, the measure of DO, which is an arc, is this arc, which is 180 because that's a diameter, right? Okay. And remember we said if you had a quadrilateral that was inscribed into a circle, that opposite angles would add up to 180. This is 100, so this has got to be 80, right? If this is 45, this is 135. If you don't know that, say 180 minus 45, and you'll get your 135. Okay, so angle Z was 80, and angle T was 135. Okay, both of these, angle 1 and angle 2, share PQ, the arc. Okay. So that means that angle 1 and angle 2 are the same size. So you set these equal to each other. X is equal to 2x minus 30. Okay, get rid of the x, the smallest x, and it's okay to be 0 on one side. X minus 30, add 30 to both sides, and you get x is equal to 30. Okay, so that's 30. Angle 1 is also 30, right? 30 degrees. This is 30. And 2 times 30 is 60, minus 30 is 30 degrees as well. Okay, supplementary angles, right? So if you want to make an equation so you can solve for x, you'd say 8x plus 10x is equal to 180. Okay, add those, you get 18x is equal to 180. And then you get divide by 18, and x is equal to 10. Okay, so 10, L, you put a 10 in there, 8 times 10 is 80. 10 into this one is 100, okay? So that's what those angles are, 80 and 100. All right, here we go to the new stuff, okay? The vertex of the angle, if it's inside the circle, then these angles are half the sum of the intercepted arcs. Half of the sum. So here's the arc, right? I want to find angle 1. Both of these are going to be the same size. So I take these two arcs and I add them up. 50 plus 30 and divide by 2. That's the sum of the arcs, and this is half of that sum, right? So half the sum of the intercepted arcs. So 50 plus 30 is 80. 80 divided by 2 is 40, okay? If I want to find angle 1, half the sum of the arcs. The angle's inside, but not on the center, right? So I need to find that angle. So here's the two arcs. So I say 130 plus 150 divided by 2. That's 280 divided by 2 is 140. Okay, so angle 1 is 140 degrees. So I'm going to put 140 right there. Now, if you want to find this one right here, then isn't that a linear pair? Angle 1 and angle 2, both of them are on a 180, a straight line or whatever. So those two angles add up to 180. So 180 minus that 140 will get me the 40. Okay, so angle 2 is 40 degrees. Okay, all right. Now on this one, you have to think backwards because they gave you one of these angles. Now, if this is 120, this one's 120, right? Okay, so the easy way to do this kind is that these two have to add up to be the same thing that these two add up to be, okay? Like these two, 120 and 120 is 240, right? Okay, if that's 240, then these two have to add up to 240 as well. Like here, wasn't that 130 and 150 was 280, and then 140 and 140 on this side would be 280 as well. So these two are 120 each, so that's 240. And then you subtract that 140 away, and you get 100 for this one. Because remember, if you add 100 and 140, 100 plus 140, and divide by 2, then you're going to get 120 for one of the angles. Okay, so if you are given this one, double it, and then subtract this one away, and you'll get this one. Okay, so angle 1, it doesn't even have an angle 1 on there. It's messed up. Okay, so x, we're looking for x. How about that? Okay, x is 100 degrees. Okay, so if you have the angle on the outside, like this one was vertex of the angle was on the inside, right? But not on the center. Okay, now if you have the vertex on the outside, in other words, this is your angle, right? Angle 1, then you subtract the two arcs that are cut off, right? So 120 minus 20, there it is. 120 minus 20 divided by 2 is going to be angle 1. So that's 100 divided by 2, which is 50. Okay, so angle 1 is 50 degrees. Okay, so this is called half the difference of the arcs. Difference means subtraction, right? So 100 minus 20 divided by 2 will give you angle 50. Up here, you add them, right? You add them and divide by 2. Here, you subtract them and divide by 2, right? Okay, here's another one like that. Okay, this one has a tangent, and that's okay. This is a secant and a tangent, but here's one arc, right? And here's the other arc. So I'm going to take my 180 minus the 60, divide by 2. 120 divided by 2 is 60. Okay, so that's 60 degrees for angle 1. That's going to be 60. All right. Now here's two tangents, right? Okay, that one's 240. So they didn't even give us this one, did they? Well, all of it's 360, right? So 360 minus 240, you can find it yourself. Okay, and you get 120. So this arc right here is 120. So if the angle's on the outside, you subtract and divide by 2. So 240 minus 120 divided by 2 is 120 divided by 2, right? Which is 60 for angle 1. So this angle is 60 degrees. And QD, which we just found a minute ago, was 120 degrees. So here's the four concepts right here. If the vertex is on the center, then the arc and the central angle are the same. Okay, angle equals arc. Okay, if it's an inscribed angle where the vertex is on the circle right here, okay, then the angle is half the arc. Okay, so 100 divided by 2 is 50. Okay, if this is the angle you're trying to find in here, Okay, if you're trying to find these angles and it's not on the center, then you have to take these two, add them up. 120 plus 80 divided by 2 is 200 over 2, which is 100. Okay, so these two angles would be 100. So if the vertex of the angle you're looking for is on the inside but not on the center, you add up, like this says half the sum of the arcs. Basically, you add these two arcs and divide by 2. Okay, if the angle's on the outside, the vertex is on the exterior. This is the vertex of the angle right here that we're trying to find. Okay, you take the two arcs and you subtract them because half the difference is a subtraction answer, right? So you'd say 100 minus 20 divided by 2, and that's going to give you your 40 degrees. Okay, so on the center, they're equal. Vertex, inscribed angle, half it. These two, whenever you find it on the inside, you have to add these two and divide by 2. If it's on the outside, you have to subtract these two and divide by 2. There you go.